First of all, I have the pleasure to introduce myself. For those who don't know me, I am Sara Barbotto, Sales Manager for European countries on behalf of BTS Bioengineering, which is the company with more than 35 years of experience in motion analysis, where we are the market leader. I am very happy today to introduce our webinar speaker, Mr. Florian Forelli, Master Kinésithérapeute in French, specialized in ACL rehabilitation and risk reduction, and with an important background in clinical research and sports consulting. I would also like to inform participants that the webinar is being run behind the scenes by our marketing team, in particular, Noemi and Julia, that we thank you. Finally, just to make the webinar more interactive, there will be surprise quizzes during the presentation of Florian that you will be invited to answer via the dedicated Zoom chat box. So please don't be caught unprepared. Okay, at this point, it is time to welcome Florian, to whom I will leave the stage to officially start this webinar.
Thanks, Sarah, for the kind introduction, and thanks, BTS, for the invitation to talk about motion analysis and decision-making in a return to play after ACL reconstruction. So in introduction, anterior cruciate ligament injury is one of the most controversial injury in the world of sports. For example, ACL injury represents only 14% of injury in soccer, but causes physiological and psychological modifications that compromise the progress and career of a soccer player, for example. So the study of Brian Forsyth showed that only 71% of injured players return to the previous level within 1 year after the injury, and only 81% return within 3 years. If the previous level is difficult after an ACL reconstruction, it also appears that this return to play and at high level can be hampered by a significant number of recurrence. The safest possible return to play is a major sporting and economic challenge after ACL reconstruction. Hence, the implementation of test battery is an important moment in the decision to return to sport and return to play, especially in soccer player. If the Isokinetic assessment, the HOP test, and the psychological assessment seem to be a gold standard, the fact remains that the battery tests are neither scientifically validated nor capable of predicting risk of recurrence. Others have highlighted the lack of specificity and ecological situation for evaluation of the soccer player as close as possible to the activity in this environment. It's important to develop an ecological test battery based on specific skills of the soccer player, for example, and on a solid scientific algorithm. This test battery is based on the 5 factors maximum model developed by Airwet, Webster, and Hurd, aimed at prediction of ACL injury risk, but also an ecological situation that result from the 11-2 assessment developed by Clairefontaine at the FIFA Medical Center in France. The 5-factor maximum model is based on anthropometric, strength and coordination, biomechanics, proprioception and balance, and psychological characteristic. Each variable corresponds to approximation of 20% risk, which allow establishment of an objective prognosis in the decision to return to play after ACL reconstruction. In addition, it's very interesting to develop quantitative and qualitative tests with reliable and recommended evaluation tools like robotic laximetry, force platform, etc. And the use of scientific algorithm predictive of ACL injuries that complements the existing test battery while approximating ecological situation. This is a clinically relevant means of being able to make a safe decision in the return to play after ACL reconstruction. Thus, it seems important to us to divide our assessment into two stages or two time, laboratory time resulting from standardized tests and field time resulting for the ecological situation specific to the soccer player environment. The first step is the laboratory time. Before performing a battery of tests allowing the return to the field, it's necessary to ensure the motor ability of the patient, such as walking without limping or the return to running. Running activity is very, very important, and sometimes it's never assessed, but it's the first ability to the return to sport and return to play. Running activity during rehabilitation of a patient after ACL reconstruction is unfortunately usually not sufficiently addressed. Often running activity is a generic term that includes running, pool, running on a treadmill with or without altered gravity, place running or educational running exercise, jogging, stadium running, etc., etc. Rehabilitative management should focus on gradually increasing running ability through a continuum of exercise and activity in preparation for sprint and side cutting. After ACL reconstruction, the return to running can be proposed very early, 2 months postoperatively, for example, or 3 months, as previously proposed, and but with normal clinical criteria: no pain, full and range of motion, good knee flexion and extension strength. However, in current clinical practice, it's during the 4th postoperative months that most patients are allowed to resume running. This time frame seems to consider the biological process of integration of the graft into the bone tightness and the general healing of the knee joint. Even if running induces little stress on the ACL, it remains a stressful activity for the femorotibial and patellofemoral joint, mainly in case of limping. A clinical assess and a test battery seems to be essential to propose to start running, and a running program will be proposed according to the patient ability found during this evaluation. To ensure optimal loading of the program, the patient voice will be essential. A soreness rules will be required to avoid major error in running training. Thus, a dialogue will have to be established and the program adjusted according to the different elements given by the patient: pain, difficulties, fear. The accompaniment will be continued until interval running protocol, running at high speed, or even sprinting to prepare for side cutting and pivoting activity and return to sport continuum. At the time of return to play, a running assessment on a treadmill or in the field seems useful to evaluate in the running pattern in correct and symmetry. Indeed, even if the dominant of the lower limb can play on a certain asymmetry, it remains rather weak, particularly on the stiffness of the lower limb. The use of an optoelectrical barrier such as OptoGate or an accelerometer tools like J-Walk or BioBeat can provide an easy way to automate this assessment. Smartphone applications such as Runmatic can also provide an overview of the symmetry on the stiffness with a record of 8 steps, for example. After a warm-up on the treadmill, a recording of the flight time and the contact time for each step is made during 30 seconds at speed of 12 km/h. Thanks to the work of Morin, we can estimate very precisely the stiffness coefficient of the limb. Therefore, an asymmetry of less than 10% for RTP is proposed. Indeed, healthy subjects present an asymmetry lower than 5%, and preliminary studies have shown that an increase in the risk of brain injury in the asymmetry is higher than 10%. The second test is a Graft Laxity test. After a normal clinical examination, a test battery can be conducted. Gockler highlighted the use of a robotic laximeter as tool to determine return to play. Indeed, studies show that the quality of movement can be impaired by too much tibial anterior translation. As a result, too much tibial anterior translation can increase MCL injury risk. In addition, graft healing is long and regional, and it's important to be able to assess graft laxity using reliable tools. Lachman, pivot shift, and direct anterior drawer seems to be recommended, but robotic laximeter use show potential for return to play. A laximeter is a passive test and established dynamic elongation curves by comparison of the two knees. The device automatically calculates differential displacements and established curve slopes. The cutoff value is the difference between the both knee of 3 millimeters at 134 newtons, for sensitivity of 70% and a specificity of 99%. During return to play assessment, a tree thrust at 250 Newton can be performed. After examination of the differential at 130 Newton, the slope differential is assessed. It corresponds to the functional instability risk, which should not exceed 10 micrometer per Newton. For an excellent result, we set the differential at 134 Newton to less than or equal to 1 millimeter and a slope differential less 5 micrometer per Newton. So isokinetic and strength tests were reported in only 41% of the study that describes the return to play criteria. Strength assessment, especially for the quadriceps, is of high importance. Quadriceps strength is correlated with functional test performance, self-reported outcomes, and risk of re-injury, even if this last point is debatable. Strength assessments are performed in different modes: isometric, dynamic, concentric or eccentric, and angular speed. If no standardized protocol is used following anterior cruciate ligament reconstruction, most studies use concentric pictures of knee extension at flexion at 60 degrees per second, normalized to body weight. Sorry. You can use like the Delaware team electromyography to determine and detect if you have an arthrogenic muscle inhibition too when you perform the isokinetic test. So the limb symmetry index expresses the performance of the operated side has a percentage compared to the contralateral side. The goal generally to achieve it's a LSI greater than 90%, but rarely reached by patient. However, the LSI may overestimate the capacities of the operated limb if the healthy limb is detrained. Therefore, clinicians should associate both LSI and reference values. The single peak torque to body weight ratio value analysis could lead to a loss of information, which is why studies should focus on the torque profile specific to the angle of the knee flexion. Since speed and absorption capacity are necessary for most physical activities, especially when changing direction and jumping, Edwards and Hall suggest use of fast speed and eccentric mode is important. Unfortunately, concentric isokinetic mode can't assess the differences in rate of force development of the muscle, which would be interesting. Some authors criticize the use of this tool because of the gap between the mode of assessment and real life. Analytical aspect in relation to the complexity of sport movements, absence of movement carried out in an isokinetic way in the real life, isokinetic speeds fast not exceeding 300 degrees per second when certain movements like sprinting are performed at much higher speed. Finally, an open kinetic chain testing of muscle usually used in closed chain is discussed. Biomechanically, this assessment is a measure of the force coupled of one segment to another one in a single plane, which we know to be different in vivo. This evaluation nevertheless remains the gold standard, but other methods of evaluating neuromuscular performance are being studied. This method, like force platform, should be more functional. Normally, hop tests resume knee function after ACL reconstruction. While some studies show good methodological quality for this test, their validity has been a challenge. According to Kotsifaki, knee performance is better assessed during landing and not during propulsion, particularly on single hop test. Similar validity issues are observed on triple hop test, especially during the concentric propulsion phase with hip, pelvis, and trunk compensation. Thus, according to Kotsifakis, the LSI obtained during vertical jumps seems to demonstrate knee function deficit more accurately than horizontal jump. The quantitative measure of the horizontal jumps to represent lower limb symmetry, systemic performance, which is essential for return to play. For a qualitative assessment, use the qualitative analysis of single leg score, QSLS, to evaluate the landing and have a feedback on knee function. Hindi dynamic values associated with an increase in the knee adductor moment constitutes a very important risk factor for ACL re-injury, as shown Paterno, for example. Hewitt highlights valgus appears within the initial 10% of landing. It's very, very important and very, very dangerous. Before a more ecological evaluation, assess the knee of horizontal, vertical, and multidirectional direction. According to the literature, the LSI must be at 90% and the QSLS less than 1 in search of an increase in the knee abductor moment. Furthermore, it's interesting to be able to determine lower limbs plyometricality and coordination in bipodal and unipodal. Regarding the coordination quality, the assessment with contour movement jump, Abalakov test must be carried out. A difference greater than 6 centimeters must be found in order to determine good coordination. Regarding plyometric quality, it will be necessary to perform squat jump and drop vertical jump. The difference must not be below 6 centimeters. A difference that exceeds 10 centimeters demonstrates good plyometric quality. Plyometrics are an essential asset in ACL re-injury preventions. With to the drop vertical jump, we can also calculate the reactive strength index, which shows the ability of the knee to store and restore energy. According to Flanagan, it must be greater than 2.5 in order to show good plyometric quality. Besides, it's very important to assess the quality of the squat jump, especially with rate force development, and the RFD should higher than 1,000 Newton per second. Some authors complete hop test by the relationships between strength and jump to determine the dynamic strength index. Dynamic strength index is a score that measures the difference between an athlete's maximal and explosive strength capacity. So next topic is proprioception and balance. So without vestibular disorder, proprioceptive alteration can be assessed via stabilometric analysis, which can be performed in bipodal and unipodal with vision or without. Evaluation of static balance could be assessed by the 2D of mobility and variation in the center of pressure, allow us to project the quality of global proprioception and postural adaptation. Stabilometry platform using offer the possibility of calculating the Romberg quotient according to which quantify visual dependence in bipodal and unipodal. Visual dependence occurs during a perceptual conflict between different sensory inputs, giving more importance to visual input and creating difficulty in changing frames of reference using vestibular and proprioceptive afferents. Romberg quotient is calculated by the ratio of the surface of the ellipse containing 90% of the point of the center of pressure with eyes closed to that with eyes open. It quantifies the importance of visual input and therefore the importance of vision in postural control. Its result is physiologically close to 93% with a difference with a standard deviation of 20%. To overcome the visual dependence, stroboscopic glasses using associated with visual motor training has demonstrated its effectiveness, in particular in reducing reaction time, in improving muscle coactivation and muscular anticipation, when then reduce ACL injury risk. In addition, dynamic balance should be assessed, for example, by the STARS excursion balance test modified or Y balance test. These two tests are also a reliable way to be able to predict lower limb and ACL injury risk. Lee found a strong correlation with knee flexor and hip abductor. Furthermore, Pilski reported that an asymmetry of 4 centimeters in the anterior distance indicates a high risk of injury to the lower limb and show 3.5 times higher risk in the event of an asymmetry of less than 90%. If injury and surgery lead to significant physiological changes, they have psychological consideration, in particular apprehension and confidence, which slow down return to play. Paterno show that athletes with a poor temper scale kinesiophobia, 11 score, 19 or more, have a risk factor multiplied by 13 for iterative ACLTs within 2 years after return to play. Strobe show an interesting correlation in male athletes between symmetrical quadriceps strength and psychological aspect upon return to play. Similar results were reported by Webster and Kim, show a correlation between symptom, function, and psychological aspect at return to play. In our opinions, the anterior cruciate ligament return to sport after injury, ACL, RSI, is the best way to assess psychological quality of the player during return to play. Langford suggests that it's possible to identify athletes at risk of no return to play for psychological reasons after anterior cruciate ligament reconstruction. Another study showed that psychological variables measured with ACL RSI are the only predictor of return to play before injury. Therefore, it's important to be able to detect the risk profiles of players who are overconfident in their return to play compared to limited physiological quality. Conversely, specific psychological preparation for return to play can be carried out if the LSI score is not satisfactory. Kitaguchi, during an evaluation at 6 months after ACL reconstruction, show cutoff value of 81.3% and a score of 55% has a predictor of a return to sports and return to play at 1 year. So the last item for the laboratory time is the vertical force velocity profile during a squat jump, for example. Samosino relied on Newton dynamic law to create the mathematical equation that allow the calculation of the value of force, speed, and power using the following values: body mass, jump height, and lower limb extension distance when pushing. It then becomes easy to obtain a reliable estimate on the force velocity power relationship of the lower limb, as well as the tracing of the individual force velocity profile using a force plates. The soccer player, for example, must perform a squat jump without body weight and add 20% of body weight to each vertical jump. The test stops when the player can't jump more than 10 centimeters. The profile thus created is compared with a theoretical optimal profile. For maximum power value, the optimal balance between the quality of force produced during the jump and the speed at which the jump is made, thus allowing optimization of performance. If the slope of the muscle's force velocity line is greater than the slope of its optimal profile, it's necessary to develop the force and strength quality. Conversely, if the slope measured is lower than that of its optimal profile, then training must be focused on the development of velocity. Yes, it's very important to consider the limb symmetry index for the global performance of the lower limb. We have some discussion about LSI because sometimes we don't have the previous values of the strength of the limb, mostly for the hop test. The hop tests have many discussion about LSI, but in my opinion, in my experience, limb symmetry index for the hop test is important to show that show the global performance on the lower limb. This global performance is very important because when the player come back in the field, all lower limb, both lower limb must be performant. So according to me and my colleague, is very important. So the trap is relative peak torque because relative peak torque is a peak torque to body weight ratio. It's another name. It's important because we have some normative values of the relative peak torques in function if you practice your sports in amateur or professional. Hence, it's very interesting because if you have a LSI about 19%, the reference values is generally the non-operating limb, but day train or not a high level of sports can decrease the performance of the knee. So it's very important to have the quantitative values with limb symmetry index and the qualitative values with the peak torque to body weight ratio to know that the patient can be returned to play in a safe consideration. So the psychological readiness I told just before is very important because it's very strange sometimes because we have some patients with poor strength, poor movement quality, but here they have a high score in a psychological test. So these patients sometimes never have re-injury. And sometimes we have patients with a good strength, good quality, good movement quality, and poor psychological readiness. And these patients have a re-injury. So psychological readiness is very discussed in the practice experience because it's important, and sometimes we see the difference. So after we talk about field time for the ecological and for the environmental situation, for the first topic, we can see the field test thanks to Clairefontaine in France Medical Center. So for the game simulation, it's very important. Welling highlighted the fact that return to play tests are not administered in a sport-specific environment. For example, it's uncertain whether performance during up tests can be transposed to a sport-specific situation in which a patient must react to opponent, teammates, and the ball. Indeed, the action of dual contact, taking information, processing and decision-making, the realization of specific movement in dual tasks, work in a situation of fatigue, or even the execution speed of specific gesture are parameters that must be observed during the return to play. However, assessment have many limitations related to the validity and reproducibility of potential tests. To limit this lack, we have empirically chosen to use a match simulation type session for 45 minutes, where the soccer player reproduces game demands according to his position and his level of practice, or directly from the group of players. The adaptation of the position and the level of the player doesn't allow an high reproducibility of the stations. This approach is not used as a test pairs. During this 45 minutes, the value of acceleration, deceleration, change of direction, jump, tackle, contact, duel, ball game, high speed running, and sprint are fixed according to the athlete-specific reference. The most intense 5 minutes are also evaluated. A quantitative and qualitative analysis is carried out through GPS tracking and biomechanical study of movement control during dynamic movement, cutting, braking, sprinting, landing, jump. Even if this assessment has limits, it has the advantage of estimating the tackle player's ability to perform the specific demand that awaits him when returning to the team. The agility test is commonly advised in the literature to control the qualities assessed during specific movement. There are agility tests for this, modified Illinois agility test, AFL agility run test, T-test, etc. And a new test, the new curved sprint test that I will talk after. This involves analysis of the athlete's ability to express their neuromuscular capacity in a context of dynamic movement, more specific to the discipline and to the demand they will encounter again the return to play. The T-test, for example, emphasizes both the quality of acceleration, in particular the rate of force development, which is the quality most impacted by ACL injury, and athletes' deceleration, but also the ability to make cutting at 90 degrees and U-turn at maximum intensity while maintaining good postural control. So the new curve sprint test is similar to the sprints found in team sport, and in particular in soccer with a curved trajectory, which requires asymmetrical movement of the athletes at maximum intensity, which requires knee-trunk control and work on the ankle-foot complex. Studies have shown that during soccer games, for example, players mainly repeat sprint of less than 10 meters, but more than 60 times. Kalbeck showed that sprints were rarely in the straight line, but in 85% of cases curvilinear. To once be more in line with the reality on the field, we recommend to use of a test recently developed by Filter. The new curve sprint, like you can show on this video. This new test curve sprint is characterized mainly by its reliability, specificity, and simplicity. It can be performed easily and precisely in the arc of the penalty area within a radius of 9.15 meters and over a distance of 17 meters. We ask for 2 sprints in one direction and then 2 sprints in other direction. And we assessed the quality of the movement during the sprints. So the fatigue test, Van Melik highlighted the reduction in quality in jumping tests under fatigue condition, and significantly in athletes who had a cell reconstruction compared to healthy subjects. Studies are contradictory concerning the role of the fatigue in the risk factor of ACL injury, muscle fatigue, However, it may be important to assess the player under fatigue and non-fatigue condition. A significant deterioration in quality and or performance with fatigue should at least alert us to the athlete's current ability to return to play at the same intensity as before the injury. This is why we have chosen to carry out op tests in the field in an ecological condition. The landing test should be performed with a force platform in a non-fatigue state and then in a fatigue situation. After athletic training session in the field, included, for example, repeated sprint ability and agility tests. These landing tests are each time carried out in single and double task. The impact of fatigue is also analyzed during game simulation, both from a qualitative neuromotor control of movement and quantitative activity intensity of point of view. The last item of the field is the horizontal force velocity profile. It's a subject of growing interest to perfect return to play, especially in soccer player. These profiles may contribute strongly to the production of the horizontal component of the reaction force on the ground, and therefore influence horizontal force. Manidukia found a decrease in maximal horizontal power with an ability to produce force at the start of the acceleration phase, 20% deficit after injury, while the value of the horizontal force is almost unchanged. This author have hypothesized that this deficit could be caused of mechanical overload in the hamstring. Therefore, players who have an ACL reconstruction with an upstream graft should have a high level of interest in the benefit from this assessment. Soccer players must sometimes combine running at high speed with a non-linear trajectory, driving the ball and cutting. Bena Raya were interested in the potential relationship between the variables of the individual force velocity profile and the ability to cut. They report that the variable of horizontal force and the power max were strongly associated with the performance in changing direction in soccer. This author showed that the ability to orient the ground reaction force vector horizontally was associated with the hands performance on cutting tests. So In a conclusion, it's a new vision of the return to play. It's outlined. The vision comes from model and scientific literature, but also from the experience of health rehabilitations and sports science professional. It's very it's multidisciplinary approach, and this vision is very interesting because the patient should have a multidisciplinary approach with physio, athletic training, medical team, surgeon. It's very important to make like that, to have the best of decision making in a safe RTP. The parameter of strength, neuromotor agility, psychological and cardio fitness are required for safe return to play, and the facts remain that the ecological situations established to study this parameter are all the more important to implement. Novel concept highlighted is this test battery for both laboratory tests, for both laboratory and field measurement parameter, which capture neuromotor control in the athletes. Neuromotor control is the crucial in terms of the quality of movement, whether during specific and analytical task or task with cognitive load, or in a situation of fatigue. Neuromotor control is standardized on ecological situation by reproduction of the cognitive load adapted to the game is the key to a safe RTP. Thus, the study of most critical variables that results from a valid scientific algorithm and specific ecological situation make it possible to evaluate motor control in a different situation, and happens to be the most efficient way to predict the risk of injury recurrence in soccer player, for example. The return to play can only be achieved by optimization of rehabilitation and athletic training after ACL reconstruction. It's important to decide as a team and with the player on the safest decision to return to play. This novel approach will not let injury decide the career of the soccer player. So for the safe return to play, it's very important to consider the cognitive load of the patient, of the player, like you want, and it's very important to consider this interaction. And you during the rehabilitation and the athletic training, it's very important to consider the cognitive load, a progressive cognitive load, like the cow continuum, control cow continuum, if you know, because it's very important, especially with the patient who had an ACL injury with non-contact, because sometimes the heterology of ACL injury mechanism is very important, because it indicates the cognitive load and the cognitive load and the deficit of the patient. So for the RTP, it's very interesting to return to the previous level, but sometimes it's very necessary to upgrade the previous level, because if you have in a good consideration an injury, it's possible to have some deficit that the medical team doesn't have seen. So to finish, I would like to thanks to my team, because we have made this idea on this RTP assessment with French guy Swiss guys, Italian guys, two Greek and American. It's very interesting to have the scientific and health professional with great experience in return to play after ACL injury to make an ideal assessment for the players. And very soon you can find this article in EGSPT. So thanks for the attentions. Thank you, Sarah, Noemi, and all the BTS team for the invitation. And if you have some question, don't hesitate to ask me. Thank you very much.